Hello, hope we're all doing well today. We're going to be going through some more notes for Unit 3, and today we're talking about direct and indirect variation. So we're going to start with direct variation. So direct variation is when one value increases or decreases the other does the same. And I'm running out of room here. So as one value goes up, as the x value goes up, the y value goes up. As the x value goes down, the y value goes down. So to set up a direct variation problem, we set it up as a product. So multiplication. Or, right here, this is the important part, y equals kx, where k is what's called the constant of variation, and this means it will form a line. If y varies directly as x, and y equals 16 when x equals 36, we want to find y when x is 54. So we're going to use that formula that we just boxed in there. So we have y equals kx. And you want to plug in the things that you know. So when y equals 16, we know that x equals 36. So k times 36. We're going to go ahead and finish solving that. So we're going to divide by 36, divide by 36, and you end up with k equals, if you divide it out, it ends up as a decimal, or you can leave it as, I'm going to, as 4/9. So k is 4/9. That's the first part. Now we need to find y when x is 54. So we're going to go back to that same equation, y equals kx. And now we're going to plug in that k that we just found. So we're going to take that and put it in for k. So we're going to have y equals 4/9 times, and now our x in this case is 54. And if you multiply that out, you end up with y equals 24. And that is your final answer. Now I want to take a second and look at this graph here because this shows direct variation. So you have, as you go up with your x value, so 2, 3, 4, 5, 6, 7, 8, as you're going in this direction, your graph is getting higher and higher and higher and higher. Likewise, if you go backwards, if you go to the negatives, your graph would keep going down further and further and further. So as your x's increase over here, your y's are increasing as well. As your x's decrease, your y's are decreasing as well. Or your f of x is decreasing. Inverse variation, on the other hand, is when one value increases or decreases, the other one is going to do the opposite. So as your x's go up, your y's are actually going to start going down now. As your x's go down, your y's are going to be getting bigger and bigger and bigger. So you set this up as a quotient. Or y equals k over x this time. So direct variation is a product, and you don't have to write this down, but you have direct is a product and that gives you y equals k times x. And indirect is a quotient, which is y equals k over x. So that's the difference between direct and indirect. One of them is multiplying, the other one is dividing. So if we want to graph y equals 8 over x, we're just going to do it the real quick way, and I'm going to give you most of the values here. If we set up a table for x's and y's, and we're going to use easy numbers that work well with this. So we're going to start at -8, and then we're going to go to -4, -2, 0, 2, 4, and 8. We could throw a -1 in there also, and a +1 as well. Okay, so -8, if we plug that in for x, it would be 8 divided by -8, which is -1. If we plugged in -4, we would have 8 divided by -4 is -2. Then we'd have -4, and then we'd have -8. 0 does not work because you can't ever have 0 on the bottom. It's important. Then if we have 8 divided by 1, that's 8. 8 divided by 2 is 4. 8 divided by 4 is 2. And 8 divided by 8 is 1. So we're just going to use these numbers here. So we're going to start at -8, 5, 6, 7, 8, and -1. So we have a point here. Then we have -4, 2, -4, -2, -2, -4, -1, -8. So this is going to be a curve that looks kind of like this, and hopefully yours will be drawn a little better than mine. Now remember, 0 didn't work at all, so this will never touch the y-axis. It'll never get to 0. On the other side, we're going to have 1 and 8. We're going to have 2 and 4. We're going to have 4 and 2. And we're going to have 8 and 1. So this side is going to look something like this. And again, I hope yours go a little better through the points than mine because you can erase a little bit easier. So this is a graph. Now this is an inverse variation graph, right? So as your x's are getting bigger, your y's are getting smaller. And that happens all the time. So right here, as your, find a good color, as your x's are going in this direction, getting bigger, your y's are always decreasing, going down, going down, going down, going down. Here, your y's are still going down, right? They keep getting smaller and smaller as you go forward. So this is a real-life example of inverse variation. If you're going a constant distance, let's say 60 miles. Well, if it takes you 1 hour to go 60 miles, then you were going 60 miles per hour. If it takes you 2 hours to go 60 miles, then you were only going 30 miles per hour. If it takes you 3 hours to go 60 miles, then you were going 20 miles per hour. So as you can see, as your time here is going up, your miles per hour must be going down. You must have been going slower because it took you longer. We're going to go through a couple examples here about inverse and direct variation. So if y varies inversely as x, and y equals 12 when x equals 10, find y when x equals 15. So the very first thing you need to notice is this says inversely. So right away you know that your equation that you're going to be using is y equals k over x. So then you plug in what you know. Well, when y is 12, we know that x is 10, so y equals k over 10. Go ahead and solve that by multiplying both sides by 10, and you'll end up with k equals 120. That's the first part. Second part says find y when x equals 15. So use the same formula, y equals k over x. Plug in what you know. Well, we're looking for y. We know our k is 120, and our x this time is 15. So 120 divided by 15 gives you 8. So in this case, our answer would be 8. It is that simple. Just plug what you know into the direct variation formula or the indirect variation formula. So, in kickboxing, it is found that the force F needed to break a board varies inversely with the length L of the board. So what we're going to do first is figure out what our constant of variation is, because that's the first part of the problem. So we don't have x's and y's here. Instead, we have F and L. So it is found that the force needed to break a board is inversely, it varies inversely with the length of the board. So that means we're going to have K over length. So we have force is inversely varied with the length. So now we're going to read the next part. If it takes 5 pounds of pressure to break a board 2 feet long, how many pounds of pressure will it take to break a board that is 6 feet long? Well, it takes 5 pounds of pressure, so force is going to be 5, equals K over, and the length of that board is 2 feet. So 5 equals K over 2. You can multiply by 2 on both sides to solve that, and you'll end up with K equals 10. So that's our first part. Now our second part. How many pounds of pressure will it take to break a board that is 6 feet long? So we're going to use the inverse variation. So y equals K over x again. Well, we don't know, sorry, I apologize, I shouldn't use y and x. I should use the letters for this problem. So F equals K over L. In this next part, it's 6 feet long. The board is 6 feet long. So we're looking for the force. Our constant was 10 over 6, which if you divide that out, you'll get F equals 1.67 about, or 1.6 repeating. Either way, that is your final answer. Example 2 down here. In a factory, the profit P varies directly. So this is going to be a direct variation problem. So profit P varies directly. So P equals KI, because it says with the inventory, which is I. If P equals 100, when I equals 50, so we're going to plug those in. Sorry, when I equals 20. Find P when I is 50. So we're going to go ahead and divide by 20, and you will get K equals 5. Go back to your original. Profit equals the constant times the inventory, or P equals KI, and plug in what you know. Well, we're looking for P. Our K is 5, and they want to know what is P when I equals 50. So P when I equals 50 is 250. And that is our final answer. The most important thing you have to look for is, are you looking at direct or indirect? And then just plug into the appropriate formula. For direct, it's y equals kx, and for indirect, it's y equals k over x. Okay, so if you can do that, you'll be absolutely fine when you are trying to complete these problems on your own. Have a wonderful night.